Hello everyone, welcome back to Logic Verify. If you are an EC student or a fresher trying to enter VLSI industry, you have probably heard about the role called Design Verification Engineer. Many people say it is one of the most demanding and also one of the highest paying roles in the semiconductor industry. But the problem is most students don't actually understand what a DV engineer really does. Some training institute sells very big dream, while many students struggle to get their first job in verification. So in this video, I will explain everything about the design verification engineer role. We will talk about who a DV engineer really is, what work they actually do, what skills are required, how someone can become a DV engineer, the realistic salary in India, the challenges in this career, and the companies that actually hire verification engineer. And most importantly, I will explain all of this in a realistic way, not by selling dreams, but by showing what is actually achievable if you prepare in the right direction. Let's start with the most basic question. Who exactly is a design verification engineer? A design verification engineer, or simply a DV engineer, is the person responsible for making sure that a hardware design works correctly before it is manufactured. In the semiconductor industry, once a chip is fabricated, fixing mistake becomes extremely expensive and sometimes impossible. Fabricating a chip can cost millions of dollars, so companies simply cannot afford bugs in silicon. And that is exactly where the design verification engineers play a critical role. You can think of it in a very simple way. If a design engineer creates the chip, then a design verification engineer proves that the chip actually works. The design team write RTL code using hardware description language like Verilog or SystemVerilog. This RTL describes how the hardware should behave, but writing RTL is only the first step. Someone must verify that this RTL behaves correctly in every possible scenario, and that responsibility belongs to the DV engineer. So what does a DV engineer actually do in day-to-day work? A DV engineer builds an environment to test the design under different scenarios. They create test bench, generate stimulus, monitor the output, and check whether the design behave according to the specification. Typically, DV engineer use system Verilog and verification methodologies like UVM to build this verification environment. Their work usually include writing test bench, generating random stimulus, checking functional coverage, running simulation, debugging failures, analyzing waveforms, reporting bug to the design team. When a simulation fails, the DV engineer investigate the issue. Sometimes the bug is in the design, sometimes the bug is in the test bench, and sometimes the problem is simply a misunderstanding of specification. So a DV engineer spend a lot of time reading documentation, analyzing signals, and debugging complex problem. Now let's talk about the role and responsibilities of design verification engineer. Many people think that a DV engineer simply writes some test code and runs simulations, but in reality, their responsibilities are much broader than that. The first and most important responsibility is understanding the design specification. Every hardware blocks comes with detailed documents that explain how the design is supposed to behave. Before starting any verification work, a DV engineer must carefully study these specifications and clearly understand all the expected behavior of the design. Once the specification is clear, the next step the next step is to create a verification plan. This plan defines what features need to be tested, which scenarios should be covered, and what corner case must be verified. You can think of verification plan as a roadmap that guides the entire verification process. After that, the DV engineer builds the test bench environment. This environment interacts with RTL design and helps check whether the output produced by the design are correct. Typically, the environment include component like driver, monitor, scoreboard, and stimulus generator, usually written using SystemVerilog and verification methodology like UVM. Another important responsibility is generating test stimulus. The DV engineer create different kind of input scenarios, including directed test, random test, and corner case test to make sure the design behave correctly in all possible situation. Next come running simulation and debugging failure. If sometime if something goes wrong during simulation, the DV engineer carefully analyze logs and waveform to understand the issue and determine whether the problem is in the design, the test bench, or sometimes even in the specification itself. DV engineer also monitor functional coverage to make sure that all important behaviors of the design have been tested. If the coverage is low, additional tests needed to be created to cover the missing scenario. Finally, DV engineer work very closely with design team. Whenever bugs are discovered, they report them to the designers, verify the fix once they are implemented, and make sure the design gradually become stable. In the end, the goal of design verification engineer is very clear: to make sure the design is fully verified and ready for silicon fabrication. Now let's talk about an important question. Why is verification so important in semiconductor industry? Many students think verification is just an additional step after a design, but in reality, it is one of the most critical stage of chip development. The first reason is the cost of silicon bug. In software, if there is a bug, developer can release an update or a patch. But in hardware, once a chip is manufactured, fixing a mistake becomes extremely difficult and very expensive. Fabricating a modern chip can cost millions of dollars, so companies cannot afford error in silicon. The second reason is the complexity of modern chip. Today's chip contain multiple processor, memory controllers, communication interfaces, and high-speed protocol. All these components must work correctly together, and even a small mistake in one block can affect the entire system. Another important point is the verification effort itself. In many semiconductor companies, verification can take 60 to 70% of the entire development time. This shows how important it is to find bugs early during simulation rather than after manufacturing. Verification is also critical because chips are used in many real-world systems such as smartphone, automotive, electronics, networking equipment, and data center. If a chip fails in this system, it can lead to serious reliability or safety problem. Finally, verification ensures design quality. Through systematic testing and coverage analysis, verification engineers make sure that features are tested, corner cases are explored, and the design behave correctly in different situations. So in simple terms, design engineer build the system, but verification engineer proves that system actually works. And that is why verification plays such a crucial role in semiconductor industry. Now let's talk about the skills required to become a DV engineer. Many students think learning just one programming language is enough, but in reality, DV requires a combination of multiple skills. The first and most important requirement is strong digital electronics fundamental. You should clearly understand concepts like combinational and sequential logic, flip-flops, finite state machine, and timing concepts such as setup time and hold time. Without strong digital basics, it becomes difficult to understand how RTL design behave. The next important skill is knowledge of Verilog or system Verilog. These hardware description languages are used to describe and verify digital design. In verification, SystemVerilog is widely used for writing test bench and verification logics, including concepts like interfaces, classes, randomization, constraints, and assertion. Another important area is verification methodology. In modern semiconductor companies, engineers often use methodologies like UVM to build scalable and reusable verification environment. These environments usually include components such as driver, monitor, sequencer, and scoreboard. You should also have knowledge of industry protocols. For beginner, protocol like APB and AXI are very common in SoC design. But in the current industry scenarios, learning high-speed protocols like PCIe, USB, or Ethernet can give you a strong advantage and make your profile stand out from other. Finally, one of the most important skills is debugging and analytical thinking. Verification engineers spend a lot of time analyzing simulation logs and waveform to find the root cause of a failure. So strong logical thinking, patience, and problem solving ability are extremely important. So in simple terms, becoming a DV engineer requires strong fundamentals, system Verilog skills, methodology knowledge, protocol understanding, and strong debugging ability. Now let's answer the most important question. How can someone actually become a design verification engineer? Many students believe that if they learn Verilog, System Verilog, and UVM, they will automatically get a job. But the reality is that learning alone is not enough. To enter the DV field, you need to focus on three things: skills, proof of skills, and visibility. First, you need to build the right technical skill. These include strong digital electronics fundamental, understanding how RTL design work, and learning language like Verilog and System Verilog. You should also understand verification methodology like UVM and have a basic knowledge of protocol used in real design. But skills alone are not enough. The second step is to showing proof of your skills. Companies want to see that you can actually build verification environment. That's why working on project like FIFO verification, memory verification, or protocol based verification is extremely important. Projects make your resume stand out. The third important area is debugging ability. Verification engineers spend a lot of time analyzing waveforms, simulation logs, and failure to find the root cause of issues. Strong analytical thinking and problem solving skills are very valuable. Another important aspect is industry visibility. Sometimes good engineers remain unnoticed simply because no one knows about their work. Sharing projects, posting technical content, and participating in discussion on platforms like LinkedIn can help recruiters discover you. And finally, you must prepare specifically for DV interviews. Companies will test your digital fundamental, RTL understanding, test bench architecture, debugging skills, and protocol knowledge. So, in simple terms, entering the DV field requires skills, practical projects, visibility in the industry, and strong interview preparation. If you work consistently on these areas, your chance of entering the semiconductor industry increase significantly. Now let's talk about the actual reality of design verification job market in India. Many students see videos online that make DV looks like an easy and very high paying career, but the truth is little more realistic. First, the number of semiconductor companies is limited compared to software companies. Organizations like Intel, Qualcomm, Nvidia, AMD, Texas Instruments, and Samsung Electronics hire DV engineers along with many semiconductor design houses. But overall, the total number of opening is small compared to typical software job. Second, competition is quite high. Every year, thousands of students learn Verilog, system Verilogs, and verification methodologies, hoping to enter the semiconductor industry. Another important challenge is the skill gap. Many students learn the theory, but during interviews, companies expect practical skills like writing test benches, debugging simulation, understanding protocol, and explaining projects clearly. There is also an entry barrier for fresher. Some companies preferred experienced engineer, but freshers still get opportunities through campus placement, internship, referrals, and strong project work. But here is the positive side. The semiconductor industry is growing rapidly, and many global companies are expanding their design and verification teams. So the reality is simple. The DV field is competitive and skill driven, but skilled engineers are always in demand. Instead of just chasing the job title, focus on becoming a strong engineer. When your skill becomes strong enough, opportunities will follow you. Now the next topic is salary of a DV engineer in India. Before I explain this topic, I want to show you a very interesting post written by a VLSI industry expert. This post talk about something many students are confused about. Why do some VLSI jobs offer very low salaries like 8,000 to 12,000 per month? Instead of just giving my opinion, I want to read a few important points directly from this post so you can understand industry perspective. So it is really written here monthly salaries of 8,000 to 12,000 in VLSI industry. Do you think the right salaries? So he has given reason service company models. They hire fresher, train candidate and place them in a client's MNCs, specifically product based companies. Client pay them per candidate or they bill as a candidate work with them acting as a contractor. Companies pay a salary after keeping their profit margin. It looks very simple, but the problem comes when client don't pay for fresher. Then service companies have changed the model. Client said we don't pay for fresher. We need a minimum 1+ year of experience. Service companies have two options. Either fake the experience or ask client to let these candidate work with them and company will not bill for the next 6 months to 1 year. So the problem is if they fake the experience, they can't hire recent pass out candidate. If they source a candidate for free, then the question is how they will pay the salary. Nowadays, it become a trend that till 3 years, all product companies considered all candidate as a fresher and expected a minimum of 6 months of free resources. Means if anyone pass out in 25, 24 and 23 are going to work a minimum 6 months for free of cost at the client side. So this is the written, it is a complete post about the salary. I will post it in the, I will attach this post link in the comment box so you can view there. So that was the main idea of the post. In simple term, what the expert is trying to say, what the expert is trying to explain is the business model behind some service companies in the VLSI industry. Because product companies often prefer experienced engineer, service companies sometimes place fresher client location without billing them initially. To recover this cost, companies may offer very low starting salaries or long bond period. Now, this doesn't mean the entire VLSI industry work like this. Many companies offer proper salaries and structure role, but understanding this model helps students see the reality behind some of the offers they receive. Now let's talk about which companies actually hire design verification engineers in India. Many people think every semiconductor companies hire DV engineer, but the reality is a little different. Only certain type of companies regularly recruit for this role. First, there are big semiconductor product companies. These companies design their own chips and therefore maintain large verification teams. Example include Intel, Qualcomm, Nvidia, AMD, Texas Instrument. However, the reality is that these companies mostly hire experienced engineer or graduate from top institute, so fresher opportunities are limited. The second category is semiconductor service companies. This is where many fresh graduates often begin their career in semiconductor industry. These companies typically provide engineering and design service to large semiconductor product companies. Organizations such as Tata Elxsi, Wipro, HCL Tech, L&T Technology Service. Scient, Capgemini Engineering are known to provide opportunities in semiconductor related service, and some of them regularly hire fresh graduates for engineering role. The third category include EDA and verification companies such as Synopsys, Cadence Design System, and Siemens EDA. These companies build EDA tools and verification IP, so DV engineers here often work on advanced protocol and methodology. Finally, India is also seeing new semiconductor startups such as Mindgrove Technologies, Signal Chips, and many more. Startups sometimes hire fresher, but they usually expect strong skills and the ability to work independently. But there is one important reality most people don't tell students. Getting a DV job is not just about completing a course. Companies actually look for strong system Verilog fundamentals, debugging ability, protocol knowledge like AXI or APB, and real verification project experience. So if you want to enter this field, focus not only on learning the theory, but also on building real practical skills and projects. Before ending this video, I want to give one honest piece of advice to students who are considering the design verification field. Design verification is very strong and rewarding career in the semiconductor industry. Engineers in this field work on some of the most complex chips developed by companies like Intel, Qualcomm, and Nvidia. But it is important to understand that DV is not a shortcut career. It requires patience, strong fundamentals in digital electronics, and the ability to consistently learn and improve your debugging skills. Instead of focusing only on certificate or quick training program, try to focus on building real understanding and practical skills. If you develop strong fundamental and stays consistent in your preparation, entering the DV field is definitely achievable. And remember, the goal is not just to get a job, but to become a good engineer who can solve a real problem. So that's all from my side. This is Logic Verify signing off.